The doors are closed. Nobody can leave now. Welcome. My name is Peter Hilton. I have a website, so I'm not going to explain anything about myself, except maybe what you need to know about why I feel that I need to give this talk. Also, follow me on Twitter, because that makes me happy if the numbers go up. Doesn't mean anything otherwise, but I like it. This talk for me is important because it's, although fairly frivolous, also fairly serious, end of the day talk, is for me related to the idea of code maintainability, and that's an important thing. That's a practical commercial type thing, which is why that's something I do training about. And this is related to the fact that as coders, we spend a lot more time reading code, including other people's code, than we do writing code. I want to challenge you a bit today. So just to check that you're all still awake, first control question is who can stick at least one of their hands in the air? OK, good. Keep your hand up if you are a software developer. You're in the right talk. OK. Most of us work using some kind of agile method on our projects. Agile software development is a thing. Mostly these days, we just call it software development. So put your hand up if you feel that you work in some kind of agile environment. Pretty much everybody. This is good thing. OK, so part of being agile is embracing change. So do you feel that as a programmer, you are able to embrace change? Put your hand up if you feel that you can embrace change. You look a little bit less sure, because you can tell this is a trick question, so I sympathize. But most of you put your hands up. So it would seem that as programmers, we are able to embrace change. So I used to think so too. Hold that thought. Anyway, this talk is about what I want code to be like. I want code to have better type. Not type as in type system, but type as in typewriter. That joke totally doesn't work in Dutch, I guess, because it's called a writing machine. But in English, type refers to the letters, the pieces of metal with letters on them. That's type. This typewriter, the IBM Selectric from 1961, was quite a sophisticated bit of hardware in its time because it had this replaceable golf ball style type head, and you could swap it out and put another one on with a different typeface. So in 1961, this typewriter had 45 fonts in hardware, and to change the font, you had to kind of open it up and swap the thing, but you could change the font on the typewriter. That's pretty cool. So did programmers use this hardware technology for their source code? No, they did not. This 1960 printout of a COBOL program run shows that there was no typography at all in 1960. This is a travesty. This is, you see, typewriters, although they were compromised, they're not very sophisticated typography. They were a reasonable compromise. And having multiple fonts on a typewriter at least let you do something. But in terms of typography, this is just a crime to typography. Of course, that's 1960, so obviously everything changed shortly afterwards, right? The next major change came about later when Windows 3.1 was introduced. So what you might not know is that Courier was commissioned by IBM for the typewriter. It was designed for the typewriter. It was designed as a compromise for the hardware to, despite the poor output from a typewriter, it had fixed width, which it had to, and it had quite heavy shapes. It was quite wide, so it was clear and legible, and it's sort of these exaggerated serifs. So it's a compromise for the hardware. Similarly, when Microsoft commissioned Courier New for Windows 3.1, it was a compromise for a different kind of output. In Windows 3.1, the font was going to look horrible unless, at normal font sizes, all of the lines were 1 pixel wide, not half a pixel or 1.5 pixels. So this meant that Courier New was basically the same typeface, but lighter, thinner lines, as a compromise for Windows 3.1. So when is this? This is decades later, right? Windows 3.1. And now Windows had kind of caught up with typewriters, right? From the 1960s. Of course, meanwhile, by the time of Windows, everybody who used to be using typewriters decades before had moved on to WYSIWYG word processors with multiple fonts and multiple font sizes and all of that kind of stuff, and were programmers using this new rich text output technology for their code. No, they were not. Courier New was widely used for source code, I suppose because it was the default monospace typeface in Windows. And it's ugly, actually. I mean, from a typographical point of view, it's really quite an ugly font. You'd only use it if you had no other choice at all. You would only use it if there were no other typefaces or if you did not have the ability to switch the typeface you were using for your code. And yet, this remains common, even now. So probably we don't use this on screen in our text editors and IDEs. I mean, I don't, and I hope you don't too, because it's ugly for that reason. But only a few years ago, I co-wrote this book, and it's the low point of my typographical career because I failed to persuade the publisher to use a proper code font. This makes me very sad. I mean, I really tried, and they just said no. They were very clear, no. So this code listing in the book, like all of the others, uses the Courier New font, which is a terrible choice for print. It's ugly, it's too wide. I mean, we had to limit the code length to 55 columns to have room for all of the other stuff. 55 columns with long variable names? Total nightmare, very difficult. And ironically, both Courier and Courier New are typefaces designed with a workaround in mind. They're working around the limitations of the hardware in typewriters and low-resolution bitmap displays in Windows. And in print, you have neither constraint. There was no need to use these workaround typefaces. But it became a cultural thing. It had to look like code, so it had to be ugly and have a typewriter look, I guess. I mean, I'm trying to be charitable. I can't think of a better reason for this. Anyway, like I said, we probably don't use Courier New on the screen in our text editors and IDEs anymore. We have there's much more exciting things have happened. And so what happened, let's say, since Windows 3.1? We got color. So this is a color television from the 1960s. Again, going back decades, typewriter era. And, OK, I'm not this old. I'm pretty old, but I'm not that old. I never had one of those. But my second home computer when I was a teenager was one of these classic 1982 ZX Spectrum with the rubber keys, which had color. I mean, pretty rubbish color and pretty rubbish games. The graphics were not very special. But in 1982, home computer for games had color. When did syntax color arrive in code? I wasn't sure. I asked around. The earliest one I know about is that in 1992, the then new version 7 of Turbo Pascal, Ball and Turbo Pascal, had syntax colors. So 10 years after my ZX Spectrum had color computer games, we got syntax color. So there was some new change. Now, syntax color is great. It helps. It makes the code a bit easier to read. I've bundled something else in here. This is yet another new typeface, Consolas, introduced for a newer version of Windows, for newer font rendering technology. So all of those C Microsoft fonts, the Consas and Calibri, they're optimized for this LCD pixel, sub-pixel font rendering so that they look better on laptop displays. Much nicer font for code. It's starting to become less ugly. Actually, I suppose maybe Consolas is the first non-ugly code font. So I guess that's something. And we had color and italics all at the same time. Exciting times. And it does not stop there. Incidentally, so if you don't know this piece of code, this is the, sorry for the digression, this is the fast inverse square root algorithm. It's got a Wikipedia page used in 3D graphics to calculate angles of reflection or something like that. Brilliant piece of code, and has the most outrageous magic number in the history of programming. It's doing some kind of floating point calculation by immediately converting the floating point number to a long and doing some nasty hackery. And somehow this is super fast because it's not floating point calculations and works. completely weird. Also actual code comments. Yeah, I love it. Anyway, but there's more, because probably most of you are familiar with code that looks a bit like this. And it turns out that not everybody has cottoned on to the very latest thing. I mean, a lot of people have. And the very latest innovation is not a new, because there's nothing new. The latest innovation is yet another thing from typography, which is the ligature. Right? So in print typography, when you print certain letters close to each other, they would overlap, and that would be ugly. And traditional typography is all about it not being ugly and about it being readable. And so you have an extra character. So the TH is not a different letter. It's an extra glyph in the font that when you type a T followed by an H, now on the left I put a space in between, on the right you get a different character that neatly joins them together. Same for the F and the J, where the dot from the lowercase j merges in with the F in a very sort of elegant, nice to see way. Some of you are completely sitting in the wrong place, so I apologize. There's only one word in English that uses the F and J, that's fjord. I think that's more useful in Norwegian, that particular one. Anyway, I digress. But the great idea, the great realization is that the technology to make this work is all about having extra glyphs, extra shapes in the font that are automatically replacing certain character combinations. And so you can do this with a code font as well for interesting effect. So one of the many popular code fonts that has ligatures is Fira Code on the right, based on the font on the left, Fira Mono. And what Fira Code does is when you type certain combinations of characters next to each other, they get replaced. And so the ASCII art of arithmetic that is most programming language syntax gets replaced with something a bit more like the way you would actually write it if you were a mathematician rather than a programmer. Plus also some funky things like cute joined together www and HTML comments and things. So this is great. This greatly improves the look of your code. And to use this, you just need to use the font. Most editors and IDEs support this, I guess. And your code becomes far more interesting. You know, greater than equals symbols look the way they're supposed to look. So you should absolutely use this. So who is not using a code font with ligatures? Who's seeing this for the first time? OK, this is great. So you absolutely should just install this at home before you go to sleep tonight. And life-changing, the life-changing magic of ligatures is going to make your code even more beautiful. Anyway, to summarize, over the last decades, we've had new typefaces, color, more new typefaces. I think the peak of the new typeface thing is, I think Pragmata Pro, I had to mention this, is the peak hipster of coding fonts. Shockingly, you actually have to pay for it. It's not free. How is that a thing? Very nice, large character set, nice for coding. But it's just another font. It's not so, you know, there's maybe more to typography than just another typeface and then the colors. So bottom line, typography is, let's say, 3,000 or 4,000 years old. And in the last 60 years, this is all we got. I am not impressed. So what if we had typography in code? I mean, it's a fairly easy question to ask. And after all, as you all claimed earlier on, you're open for change, right? OK, so what else is changing in our programming environment? We used to write code on tiny little square monitors. And now we have like nice widescreen monitors and several, as many as possible. You should definitely have more monitors. Who has less than 2 monitors when they're writing code? OK, so if any of your employers are also in the room, you absolutely have to buy these people more monitors. 2 is the absolute minimum number, and 3 is pretty good, I guess, for coding. You should have more monitors. And when you add more monitors, you tend to put them next to each other. Our desktop is getting bigger sideways. So the available space we have is like this wide expanse of desktop, which is what is a good thing. That's the way it should be, because that's like your field of vision is wide. And yet, as Java coders, we write Java code, or other languages. This is not a language-specific gripe. We write Java code that is not wide field of vision shape. We write Java code which is this shape. And obviously, we sort of know that classes are supposed to be short, single responsibility kinds of things. And yet we keep adding lines of code. And they get longer and longer and longer. And this particular class is way longer than this. I mean, this is only the first, I don't know, the first 800 lines or so, kind of really small. And I mean, realistically, how many classes have you got that are more than 2,000 lines long in your code base? I mean, we know it should be none. But we don't. Anyway, so we know we have a lot of code, and it's too long, and it's this shape. And our monitors are this shape, and then there's a whole other monitor that at this point is just empty and blank. If only there was some way of putting more text on a wide rectangular space, we could have multiple columns. Ooh. So how would this work? I mean, I guess you just automatically flow into the next column. And this is still not the whole class, obviously. So you'd scroll sideways, I guess, but at least you'd see more of it. And if you got another monitor, you'd see twice as much. So that would be pretty cool. And I'm looking at this, but navigating around this is pretty difficult because you scroll sideways, backwards and forwards a bit, and you don't know which column is which, and you just can't find anything. But then I had this other idea, like what if, and it's going to get a bit, you know, a bit difficult, but bear with me. What if we didn't have to have all the text in the same size? Like we could make the method names, the method signatures, bigger. So I haven't gone very far yet, and I've already gone way beyond any programming environment I have ever seen. So here's a question for you to think about. I don't want the answer, but why has nobody done this? I don't know. After all, we're all ready for change. I mean, nobody's kind of stuck with their tools as they are, right? It's a bit messy like this. It doesn't really line up. So I was playing with this, and I thought, well, if I draw some lines, then it's a lot tidier. Just put some lines between the columns and horizontal lines between the methods, and it's much easier now to find your way around. It's got a bit more of a look. Of course, I don't know if you know where I'm going with this. Maybe it's obvious. I didn't make up this style. This is the visual language of old-fashioned newspapers. I have reinvented newspaper style. I haven't reinvented it. I've just copied it. I've just shamelessly stolen newspaper style and used it for code. And what I've done here is I have now advanced to the level of layout and typography of edition 1 of the Oxford Gazette, which was the very first newspaper published in England in 1655. So, I mean, color is the only new thing we've got in 360 odd years, because they didn't have color printing back then. So that was just a train of thought about code based on these wide monitors. And they just keep getting wider. I'm not sure if this is actually really a gaming monitor, or, as I discovered, this model can rotate. It's a Java coding monitor. Isn't that fantastic? But maybe we could kind of use the space a bit better. So let's roll with this a bit. I mean, what if we actually used color and maybe some other things as well? So I want to make you see that code always looks like it's come out of a typewriter and doesn't have to. So the source code I showed earlier is used in computer games, 3D graphics. This stuff, the fast inverse square root algorithm, used, for example, in OpenArena, Quake 3 clone. I think it originally comes from Silicon graphics workstations from way back. It's a bit unclear. And so I figured that the same code I could use not only in different typeface, but more than one typeface in color and columns, because it turns out space goes in two directions, not just down. And I rewrote that code. Well, no, I didn't rewrite the code. Sorry, this is important. I left the code exactly as it was. I just reformatted it like this. Because not every token in this bit of code is equally interesting or important. It's the magic number in the middle is the first thing you should look at when you read this code to realize that something interesting is going on. And I know that none of you like comments. I mean, there are people, I'm not going to ask you to admit it, but there are people who change the syntax coloring to put comments in white on a white background. Or you could put them in the sidebar. I mean, I guess they'd be kind of out of the way there. Now, I fiddled with this. I did this manually. And so this is first important point. This doesn't do itself. This isn't automatic. I'm not thinking about tools that would do it automatically. I'm thinking about layout and typography as a human artistic endeavor. There are these people called designers who make posters with text and make it look nice. And they make infographics so the information pops and you can find your way to the more interesting information more easily. So this, if this is in your code base, should not be buried in the source code repo and nobody ever sees it. This should be on a poster on the wall in your room, and it should be big. And there should be other posters for other interesting code. Of course, it's probably not this kind of style, because this is the kind of the computer game style I was thinking about. But I've never written computer game code. I've always written business applications, corporate code, which is less exciting, but interesting in other ways. I think corporate code should look a bit more like this, a bit more serious, a bit more kind of company report style. Now, obviously, please excuse the non-breaking spaces in the class name, but I just needed to separate the words a bit. So it's some kind of factory. So I want a photo of a factory. I want a photo of a control room in the factory. And the photo should sort of reflect the mood, the style of the code. You know, serious and somber and not exciting. I showed this to some people recently, and we got into a conversation. I realized that actually you could do more than just photography, because photography is sort of horribly static. It doesn't change. And computer graphics, like CGI, is getting really quite good these days. So actually, they should just be rendered. You know, think of a scene out of Half-Life or some kind of grungy computer game. And if this code has test failures, there should be fires in the background and broken equipment. I want animation. I mean, I want to see. I want this image to take me into the world of this class, and I want to have a feeling for it, because I don't want to have to read the code. I mean, if I do have to read the code, then at least I should format the documentation comments nicely. I should move the really boring stuff like the metadata Javadoc tags and the license information into a sidebar. I should tastefully use multiple colors, but not go overboard, a couple of different fonts, some different font sizes, and I should focus on readability. Now, I mean, I'm not even a designer, but this was quite fun to do. Oh, look, you can put comments in the sides that don't get in anybody's way. So the style I've blatantly copied here is simply a textbook, a reference manual. That's what this looks like. This looks like a programming textbook. And most of us read books sometimes. I mean, books about programming, and they have this sort of style. And they're not designed by programmers. If they were designed by programmers, they'd just come out of a typewriter in Courier, which would be horrible. And if you've got more monitors, you can view more pages at the same time. There's one more change as well that I've made here that is maybe not so obvious at that size. But you might notice, if I zoom in a little bit, that there's something else. I've made a different choice here. There's something else that's changed, which is a big change in recent years, is the screen technology we have. We have high-resolution screens. If you have high-resolution screens, you can see the fine detail in letter shapes. If you can see the fine detail in letter shapes, then you don't need to use ugly fixed-width typefaces. Fixed-width typefaces are unnecessary. Things don't need to line up vertically. If things lined up vertically, then I'd be fiddling with the code to line things up, and it would pollute my diffs with white space and weird stuff like that. If we have high-resolution monitors, then we can have much more interesting typefaces. And if you don't have to have a fixed-width typeface, you have much more choice. You can do much more things. So Fixed width typefaces, that definitely needs to go away. Turns out, and I've tried this very successfully in the past, you can, if you're doing pair programming, you can really wind up your colleagues by switching the typeface to something proportional like Verdana in Eclipse or IntelliJ or whatever you use. Because the sky does not fall, civilization does not end, it does still work. And if you're using long variable names and complaining about length, it turns out you fit a lot more on each line. And the important difference also is that monospace typefaces are less readable. If you had to read a newspaper article or a novel in Courier, it would take you longer. That's important, because as I said at the very beginning, I pointed out, we spend much more time reading code than writing it. So why do we not optimize for that? Why do we optimize for being able to type our code using 1970s era text editors? So my first claim, well, I've made many claims. My first ridiculous claim is that every team should have a designer on the team who picks the most interesting code and brings it to life in print, on the wall. There should be, with every major release, a coffee table book of the most interesting code that you should hand over to new people who join the team. This is the selection of the code we're most proud of. And they will bring this code to life, and they will make it interesting. Now, the idea of hiring a designer on your development team might seem outrageous. How are you going to get budget for that? But if you work, say, for a product company, there are already designers, and they work in the marketing department, where they are wasted. And people say to me, but if you make a poster out of this code, we know that the code is going to change. So what do we do about that? Well, the answer is simply you just throw it away, make the changes, and make a new poster. Because the designer in marketing is making, at the moment, they're making product brochures that have a lifetime of, if you're lucky, a few months before they become out of date. And yet, when we write code that matters, if you were in Roy's talk this morning, we're talking about years. Interesting code, successful systems lasts for 5 to 10 years, more if you're lucky. And yet, in software, we talk about legacy code as a bad thing. Software is the only field in which legacy is negative. In everything else in society, legacy is a positive thing. So, that's just a few ideas for you to think about at this stage in the afternoon. Turns out, this is not what's happening. There are some new things, but not this. So what is happening? Let's jump back to the 1970s. Who has seen this presentation by Brett Victor called The Future of Programming? Does that mean that almost all of you have not seen this presentation? Okay, this is excellent news, because I get to be the person to tell you, do not go to sleep tonight until you have found this on YouTube and watched this presentation. It's way better than the one you're in right now, and you will really enjoy it, and this is probably the best thing I can give to you today. It's a gift. Watch The Future of Programming. His essential thing, and there's a good bit of theater here, is that he pretends that it's 1973. It's not from 1973, it's from a couple of years ago. But he pretends that it's 1973. And he talks about all of the wonderful things that happened in the 1960s. And he's optimistic and excited about all of the wonderful directions that programming is definitely going to go in the next 10 years. And at one point in the presentation, he says, I am totally confident that in 40 years, we won't be writing code in text files. That would indeed be pretty tragic. He said, I do think it would be kind of a shame if in 40 years we're still coding in procedures, in text files, in sequential programming models. It would suggest that we didn't learn anything from this really fertile period in computer science. That would be a tragedy. But I'm totally confident that's not going to happen, because we're also excited about change. As agile developers, we embrace change, don't we? So where's the change happening? So I want to have a brief look at one of the areas where there is change. Visual programming. I've picked a couple of examples of visual programming. So visual programming is when you don't write text files. pretty much everything else. So one example, which I work with at the moment, as part of my day job, is this business process notation. This is a standardized notation used to model and execute business processes. Okay? So the idea is that you have some kind of drag and drop visual tool. You drag and drop the symbols, and you can execute this. And that does something interesting and useful. Another kind of visual programming is Scratch. Who's heard of Scratch? Who's come across Scratch before? So Scratch is indeed justly popular, designed for children, programming environment for children. Also visual. This time it's block-based. Blocks in the sense that you have visual blocks that you click together and make programs. Now, it turns out that these two wildly different notations for wildly different audiences share basic coding constructs of procedural programming. You can do a thing. You can do another thing after you did the first thing, like one line of code after another. You can have conditions. So you can fork your program and you can loop. And once you can do this, everything else is pretty much syntactic sugar, and you can write code. The big difference between BPMN, Business Process Model and Notation, and Scratch is that Scratch is designed for children. BPMN is designed for operations managers. Scratch is way more sophisticated. BPMN is really quite simple, simplistic even. I mean, it's just very limited. BPMN is Scratch for managers. However, despite the simplicity, there are some interesting properties that it has because it's not constrained to being in text files. So one of the things that you can do in a text file is zoom out, and it's not very interesting because it always looks like this. You get pretty much nothing from this picture. Whereas in a process model, if you zoom out far enough that you can't really read the text, there's still some kind of visual structure. And you can read something into that. And actually, you have some freedom. I mean, I can move something a bit up or a bit to the left, and it doesn't change the semantics. It's a bit like deciding whether or not to put a blank line in code. Scratch also, if you zoom out, and there's a zoom control in the editor, lets you see something interesting. I can't read the code. I can't read the words, which are white here. But I can get some sense of the structure of the program, much more so. So yeah, imagine a coding environment where zoom was a useful idea. There's another thing that you can do in Scratch is, because it's not stuck to tokens in text files, you can localize the code and view it in different languages, which is pretty important because it's aimed at kids who aren't all coding in English. So it supports multiple languages, a lot of different languages, even Dutch. Who knew? And this is all part of a development environment, which is, again, really quite sophisticated. It's web-based. You have a kind of a live preview, so you can do live debugging. It's not fully sequential. You've got multiple parallel things going on. It's some kind of real-time event-driven programming environment. That's pretty cool. And it's very popular. So if you go to the Scratch Explore website, and I have to kind of update this slide every time I show it to people, there's 32 million projects on here. Now, obviously, you're not impressed because there are more than 60 million GitHub repos, more or less twice as many. But these are mostly kids who are producing this. I mean, they've got homework to do. Where do they get the time? Who knows? So this is a very different idea, and it's gone in a very different direction to what you would end up with if you had some kind of constraint. You've got to put the code in a text file. For both of those environments, that wouldn't have worked. Interestingly, both for the managers and the kids, that might have made it unacceptable, not interesting, too much like programming. In the other direction, sometimes professional programmers like ourselves point at things like this and say, that's not real programming. That's a very dangerous idea. It's also wrong. Here's one more. So this is not for managers, and it's not for kids. This is Luna language. This is a pretty serious programming language. It's a Haskell-based, or Haskell-type language with a Python-style syntax, so it's less scary than Haskell, but it's fully functional. And what's unusual here is that on the right-hand side, it has a fairly conventional text-based representation. but with a simultaneous graphical representation, which is what you see on the left. And they don't show the same level of detail. They don't quite show the same things, but they are entirely equivalent. And it has a development environment where you can switch between the two. This is a kind of trivial example, so the diagram's not so interesting. On a slightly more interesting example, the diagram can start to show things that are not as immediately apparent when you're looking at the code itself. So for example, the colors here represent types. You don't know which type blue is, but you do know that it's not the same type as green, for example. It gives you some idea about what's going on in this code. Also, it gives you a really quite cool visual debugger that you can't do with code, or text-based code, as we normally think about it. So if, for example, so the circles are, let's say, their function calls or their assignments to some value. And the lines are essentially data flows. I don't understand this well, so I can't explain it properly. But I saw a demo of this where if one of these nodes is fetching JSON from a web service, then you can actually run this and see the JSON appear underneath the circle. And if the next one transforms that JSON somehow, you would see the next bit of JSON. So it's like a two-dimensional visual debugger. That's something that you just can't do in a textual paradigm. That's pretty exciting. And I spoke to one of the founders of the company, the startup that's making this. He said that he joined the company as a languages expert, Haskell programmer, had no interest in this visual stuff. 3 years later, he wouldn't want to be without it. So we don't know what we're missing. We don't know what we don't have. But what's interesting is that for the most part, what's interesting to me at least, the big innovations in the visual programming side are coming from people who don't really identify as programmers. And it's for people who don't identify as programmers. And that worries me a little bit. The reason it worries me is that it turns out that programmers are extremely conservative. We'll let you change some things. You can change my JavaScript framework daily. Apparently, we like that, and that's OK. But if you want to suggest that we're going to have a different number of characters as our maximum line length, or that we might have more than one type, font size on the screen, or that we're not saving the code in text files, we're horribly upset by this. And I don't really understand why. The more I think about it, the less I understand it. So here's an idea. One of the things that programmers love to do is build software for themselves, or at worst, other programmers, because it means that they don't have to talk to normal people to figure out what's needed, customers and other when I say normal people, I mean non-programmers. And the worst thing about our text-based toolchain is that all of the core utilities were written as Unix command line tools decades ago. They're all done. And that's why we're kind of stuck into this text-based paradigm, because all of those tools would stop working. But imagine if we got rid of the text files and we had a different style of a different representation of code, then we'd need to re-implement all of those tools all over again. So we'd have to build lots of new programming tools for ourselves and for other programmers, instead of building business applications for business people. Surely that would be much more fun. And it turns out that when you build a visual editor for the business process notation I showed earlier, and you have version control, you do need diff. And so I have colleagues who have built a visual diff for these process diagrams, and they had to build it from scratch. The underlying representation is XML-based, but it's structured hierarchical, like an AST. But they had to kind of build this tool from scratch, because command line diff is useless. Because diffing the XML doesn't show you that you moved one of the boxes up a little bit. That's what you want to see in a diff, that this thing has moved. So that's the opportunity as well. I mean, you should be excited about the idea of new things. So carrot and stick, that's the carrot. The stick is this. Now, as I said, I'm old, but not that old. I'm not old enough to have ever seen one of these for real. But this is, so it's not a real one, but this is a picture of a punch card. This is a picture of an 80-column punch card. And if I understand it correctly, writing code, if you go back far enough, used to mean making holes in one of these that would represent the binary instructions of machine code. This was later replaced by assembly language. It's worth noting that when it was replaced by assembly language, the people who wrote kind of these things, they said, well, assembly language, that's not real programming. How do you know what's really going on? But eventually, assembly language caught on. Was later replaced by higher-level languages like, I don't know, like Fortran. And guess what the assembly language programmers said about Fortran? They said, well, that's not real programming, because when you write this, how do you know what's really going on? Guess what happened when garbage-collected languages were introduced and all sorts of, gradually more modern stuff? So be very suspicious of the temptation to point at something and say it's not real programming, because history is not on your side. And so one of the discussions or one of the newspaper headlines that you might see occasionally in the Java world is the idea that Java is the new COBOL. I mean, Java, renews itself and whatever, but yeah, there are other kind of newer languages. And so we get into very heated discussions about which programming language is newer or more modern or hipper, and should we all switch to Go or Scala or something? I mean, maybe you should. I don't. That's not the discussion. That's not what I want to talk to you about now. I want to suggest that those discussions are entirely beside the point, because all of these languages are really just modern versions of either Lisp or Fortran, I suppose. And they're all basically the same thing. So my challenge is that you should not worry about Java being the new COBOL. You should worry about ASCII text files being the new punch cards. Because the future will not look like today. Code of the future will not look like today. The code we produce, when we read it, when we write it, has the same look of the typewriter. We're stuck with pretty much a 70-year-old look for our code. And yet, the kids who are today, for some of you, your kids, literally, who have been learning Scratch at school when they are, let's say, 8 years old, growing up with that, what are they going to do later on when they've gone off to university and they've studied and they've learned programming and then they want jobs at the companies that exhibit at conferences like this? And they go off and work for these companies. Are they going to be happy with writing code in text files? I'm not sure, because like Brett Victor, I would love to say I'm totally confident that that's not going to happen. But maybe it will. But maybe it won't. And so today I'm feeling optimistic. They will not accept this, and they will write new tools. And what I cannot know today is that when these kids invent, let's call it enterprise Scratch, I don't know what it's going to look like. The only thing I know is that enterprise Scratch will not look like a text file typed on a typewriter. That's all I've got for today. We have a few minutes available for questions. Before you ask questions, pull out your apps and rate the phone. Pull out your phone and rate the whatever, the thing. Rate the talk. Are there any questions? None. Oh, okay, we have one here.
What about the project editors like MPS from JetBrains? They take part with the abstract tree, and it can be shown as almost anything. Like, God can be a text, can be a graph, can be a text representation.
Okay, so the question, if I understand it right, is what about editors like JetBrains MPS? One, I don't know, because I've not used it. I don't know who else is using that. I can give you a generic answer about most of the advances I've seen. They tend to focus on everything except the typography, like having multiple windows or having tree views. Like the Luna thing I showed, it still had the kind of code with a fixed width typeface. So most of the newish things have this blind spot for typography, and they look somewhere else. And these are all useful advances. But somehow, zero typography is sacred and not changed. So that's my impression in general. And if you can correct me and show me a demo of how JetBrains is actually doing something that isn't text files, then I'll be very excited. There was a question here-ish. Yes, hi.
What was the game on the ZX Spectrum?
What was the game on the ZX Spectrum? I actually don't know, because I didn't have it. I mean, I had to look for the screenshot. I don't still have the thing. Sadly, I don't know. Gladiator, apparently. Right. Was that... I may have played that game. A question up on the gallery.
What do you think the future of commenting in code will be? Because I heard that you should
What is the future of commenting? I believe that by the time you're 35, you should have written a correct, useful code comment. Failure to write comments is just failure to write, mostly. I have another presentation about why you should write comments, but we don't have time for that, sadly, so you'll just have to be spared that and go and have a beer downstairs or a Coke instead. Any other questions? Yeah, one of them.
So why not write something that creates that newspaper-style UI yourself?
Why haven't I already implemented all of this stuff? Excellent question. Excellent question. I'm too lazy, and so my strategy is instead to present this idea to a much larger group of people in the hope that one of you will feel compelled to go and implement these ideas and give me the credit when you do so. Next question over in this corner. Yeah, I can. The slides are online on my website as well, by the way. There we go. Oh, skipped one. Obviously, I had to use Spring to find a long enough package name. Question?
What's the best visual programming environment or language that you've seen?
What is the best visual programming environment? I don't really know because I'm not a kid or a manager, and they're not really for me. I think all of them are good. But actually, the question kind of doesn't make sense. So with programming languages, we have general-purpose programming languages, and they're designed to be for everything. So you can almost ask that question, what is the best programming language? But what is the best visual programming language as a question makes less sense because they tend to be much more special purpose. So the business process notation is not for making general purpose software. It's for building form-based workflow applications, and Scratch is for games or art things for kids. So which one's better? Well, the one that's closer to the purpose you're doing. Also, there's probably not enough of them for one to obviously be better than the other. I don't have any useful answers. There are quite a lot more out there that I haven't found out about or had time to research. Question over this side. Why did the visual drag-and-drop programming application builder environments disappear? First answer, they didn't disappear. Many of them are alive and well. There are things like Mendix, so it's an application builder. The business process thing that I work on is a similar kind of thing. Another reason they disappeared, the ones that did disappear, is that they were really trying to solve the problem wrong. One of the things that visual programming butts up against is this deep wish among business people to not need programmers. And you can sell business people very expensive things if you let them believe that they will no longer need programmers. Obviously, this doesn't work, and so that's the main reason why these products failed. The ones that succeeded found some other subtle way to do it. Alan Kelly, who's a very interesting conference speaker and coach and trainer, said that whoever says, and using this tool you can replace the programmers, just became the programmer. Okay, that's time exactly, so thank you very much.